Hello everybody and welcome back to another episode of Edmund's Maths. Now, in the previous video we defined the inverse incomplete beta function, which has a defining formula like this, where now the integral goes from t to the inverse function, dt of t to the n minus 1, 1 minus t to the n minus 1. And today we want to have a look at how to sketch it. But this formula is bloody horrible. So how are we going to sketch it using this? Well, we don't. Instead, we use our previously gotten sketch of the incomplete beta function, where we know the incomplete beta function initially has a gradient of infinity, climbs up, and the gradient slowly decreases to 0. Now, as we all know and love, the sketch of an inverse function is just that function reflected in the y equals x line. Now we know this y equals x line actually falls below this function because the incomplete beta function, when x is 1, is equal to pi by 2. And of course pi by 2 is, last time I checked, greater than 1. So it looks like this. Now, finding the sketch of the inverse incomplete beta function is very easy. So we're just going to reflect this in the line y equals x. Therefore, the inverse incomplete beta function will start off with a gradient of 0. Then the gradient will slowly climb up until it has a gradient of infinity. And at this point, x will just take the value of the incomplete beta function here. So x will be equal to pi by 2. And likewise, the value of the inverse incomplete beta function here will take the value of the beta function when the beta function is actually at the value of x, which is equal to 1. Okay, so now I want to sketch the inverse incomplete beta function on its own set of axes. So therefore, the inverse incomplete beta function looks like this. And we'll be using this in another video where we look at how two bodies in deep outer space will actually fall towards one another, and the trajectory will actually be an inverse incomplete beta function, or at least a function of it. So stay tuned, and thank you for watching.